The James Webb Space Telescope is turning the universe upside down. In just a short time, it's uncovered galaxies that shouldn't exist, spotted worlds that might host life, and shattered everything we know about space. JWST isn't just looking into the past, it's rewriting the future of space exploration. Let's start with one of the most shocking revelations: galaxies that simply shouldn't exist. Soon after JWST sent back its first images, researchers were stunned by what they found: a group of ancient galaxies that defied everything we know about the early universe. These galaxies were not only incredibly old, having formed just a few 100 million years after the Big Bang, but they were also enormous. One of them was estimated to contain 100 billion stars, roughly the same size as our Milky Way. Now, why is this so unbelievable? Based on our current understanding of galaxy formation, the early universe should have only contained small, fledgling galaxies that slowly merged and grew over billions of years. But these massive galaxies seem to pop up out of nowhere, fully formed and gigantic much earlier than expected. Researchers called them universe breakers because their existence seemed to break all the rules of cosmology. How could these galaxies have grown so large so fast? One theory is that these are not actual galaxies, but quasar-powered galaxies, galaxies whose centers are dominated by supermassive black holes that emit so much light they give the illusion of immense size. Another possibility is something called bursty star formation, where stars form at an accelerated rate. Either way, these galaxies have thrown a cosmic wrench into our understanding of the universe. JWST also uncovered something equally puzzling: ancient supermassive black holes. In April 2023, the telescope discovered the oldest known black hole, about 570 million years after the Big Bang, dubbed Sears 1019. This black hole weighs in at about 10 million times the mass of our Sun. Just a few months later, JWST found an even older black hole, one that formed only 400 million years after the Big Bang. So why is this surprising? According to current models, black holes take a long time to grow to such massive sizes. They form when giant stars die and collapse in on themselves, but it takes time. Millions or even billions of years for them to accumulate the matter necessary to reach the enormous sizes we observe today. The fact that these black holes were already so large so early in the universe's history defies those models. Scientists have proposed several ideas to explain these cosmic giants. One theory is that instead of forming from dying stars, these black holes may have formed directly from collapsing clouds of matter. Another possibility involves something called population 3 stars, a hypothetical class of stars made entirely of hydrogen and helium that could have existed in the early universe. These stars, burning incredibly hot and fast, might have left behind black holes that grew at an accelerated pace. But here's the kicker: there's even a theory that some of these black holes might predate the Big Bang itself. While that's a much more speculative idea, if it turns out to be true, it would completely revolutionize how we understand the universe. Now, let's journey to the Orion Nebula, where JWST has made a discovery that could change how we think about the formation of stars and planets. The telescope found 40 pairs of Jupiter-mass objects known as jumbos. But these aren't just any large planets. These binary objects, each as massive as Jupiter, appear to be floating freely in space without orbiting any stars or other large celestial bodies. Now, this is wild for several reasons. First, based on what we know, an object as small as Jupiter shouldn't be able to form on its own. It needs the gravitational pull of a star system to coalesce. But here we have these free-floating binary objects that seem to have formed without a star's influence. They're just out there, hanging around in space together. What's more, they're paired up. You'd expect rogue planets to exist, but binary pairs? That's almost impossible. The chances of two planets getting kicked out of a star system together and staying bound to each other are astronomically small, yet JWST found not one, but 40 such pairs in a relatively small region of space. This discovery raises so many questions. Are these objects planets or something else entirely? Could they represent an entirely new category of celestial bodies? We don't know the answers yet, but this finding shows us that our understanding of planet and star formations is far from complete. Not all of JWST's discoveries are about distant galaxies and black holes. Some of them are closer to home, like the time JWST accidentally discovered a previously unknown asteroid in our own solar system. While testing its mid-infrared instrument, JWST was pointed at the main asteroid belt between Mars and Jupiter. The target was asteroid 10920, but instead, the telescope detected something else, a much smaller asteroid that had never been seen before. This asteroid, estimated to be about 100 to 200 meters long, the size of the Washington Monument, became the smallest object ever observed by JWST. What makes this discovery important is that the asteroid belt acts as a kind of fossil record for the formation of our solar system. Each object within it can tell us more about how the planets and other celestial bodies were formed billions of years ago. But small asteroids are notoriously hard to detect, which is why this accidental discovery is so exciting. It opens the door to future JWST observations of similar tiny objects, which could give us invaluable insight into the early solar system. In the coming years, JWST will focus on studying asteroids smaller than 1 kilometer in size, and who knows what else it might find. And finally, we come to what might be the most thrilling discovery of all: potential signs of life on an exoplanet. Back in 2015, the Kepler Space Telescope discovered an exoplanet called K218b, which orbits a red dwarf star 124 light-years away in the constellation Leo. This planet is particularly intriguing because it lies within its star's habitable zone, the region where liquid water could potentially exist. Fast forward to 2023, when JWST took a closer look at K218b and made a groundbreaking discovery. JWST's spectroscopic analysis revealed the presence of water vapor in the planet's atmosphere. But that's not all. The telescope also detected traces of dimethyl sulfide, DMS, a compound that, here on Earth, is only produced by living organisms, primarily by phytoplankton in our oceans. Now, before we jump to conclusions, it's important to note that these findings are preliminary. While the presence of DMS is exciting, it's not yet conclusive evidence of life. There could be other non-biological processes that produce DMS on K218b. Further observations and analyses are needed to confirm whether this truly represents the presence of microbial life on another world. Even if K218b doesn't turn out to host life, the fact that JWST was able to detect these compounds so early in its mission is a testament to its incredible capabilities. The search for life beyond Earth is just beginning, and JWST is already helping us get closer to answering one of humanity's biggest questions: are we alone in the universe? In just 2 short years, the James Webb Space Telescope has revolutionized our understanding of the universe. From impossible galaxies to ancient black holes, rogue planet-like objects, hidden asteroids, and potential signs of life, JWST has already given us more than we could have ever imagined, and it's only just getting started.